guys. In this video I'm going to show you how to find the derivative using definition of derivative. So we have a lot of equations right here. I'm going to show you one by one. So let's begin with the first one. Before we do this question, first we have to know what is derivative equation is. So derivative equation is something like this. F of x equal to limit, we have to use limit as h approaches 0, f of x plus h minus f of x over h. This is the derivative equation. First apply this equation for the first question, and if I do that, let's do this. So f of x plus h, I have to find f of x plus h. I'm doing separately, so it will be easier. So what we have to do is, first of all, for the x, I am going to plug x plus h for every x. So for in this case I'm going to plug 3 times x plus h minus 8. So if I expand it, it will become 3x plus 3h minus 8. And for the x value, it's going to be same as this. If I plug x for x, it's going to be same. Now I can directly put that one here. Limit h approaches 0, and for this one I'm going to put this value right here. It's going to be 3x plus 3h minus 8, and minus within the bracket I am putting the same value right here. F of x is equal to 3x minus 8. 3x minus 8 and over h. And if I expand this one, it will become 3x plus 3h minus 8 minus 3x plus 8, because this one minus minus, so it will become plus 8 over h. So 8 cancels, 3x cancels. The one we have left with is limit h approaches 0, 3h over h, and h cancels. Therefore the final answer is 3. So 3 is the derivative of this question. Let's do the second question. So it's asking f of t is equal to what? So instead of x, I'm going to put t for this one. Limit h approaches 0, and this is going to be f of t plus h minus f of t over h. So let's find f of t of h, t plus h. The value is 2.5. Instead of t square, I'm going to put t plus h square plus 6 times t plus h. So if I expand this one, 2.5, if you expand t plus h square, it will become like t square plus 2th plus h square. So this is the expansion of adding squares, and this is going to be plus 6t plus 6h, and then I can expand this one. It's going to be 2.5t square plus 5th plus h square plus 6t plus 6h. Now I can directly put that value here. It's going to be limit h approaches 0. This is the value in the top for f of t plus h. 2.5t square plus 5th plus h square plus 6t plus 6h, and this is just the ft plus h, and f of t is going to be same as this value, 2.5t square plus 6t, because it's already plugged, t is plugged here, and it's the value right here. So it's going to be 2.5t square plus 60, right? 60 over h. Now let's see what we can cancel. Let's expand it in one more step. Limit h approaches 0, 2.5 t square plus 5th plus h square plus 60 plus 6h minus 2.5 t square minus 60 over h. Now I can cancel 60 60 and 2.5 t square 2.5 t square. The thing we have left is with 5 limit h approaches 0, 5th plus h square plus 6h. Wait a minute. So this is h square, this is 2.5 h square because it's multiplied by 2.5, right? 2.5 h square, 2.5 h square over h. Now I can take the h common. It's going to be limit h approaches 0, and if I take h common, it's going to be 5t plus 2.5h plus 6 over h. H cancels. Now I can plug the 0 here. If I plug 0 for the 5t, there's nothing to plug because I can plug the 0 for h values. So I can only plug 0 for h values. So if I plug 2.5h, it will become 0. So the only thing we have left is with 5t and 6. It's going to be 5t plus 6 is my final answer. Now this is not the only question. The question is asking find the derivative of the function using definition of derivative. State the domain of the function and the domain of its derivative. And for the first question, if you see the equation, it's 3x minus, it's a straight line, it's going all the way. Therefore the domain is all real number, and if you find this find the f of x derivative, it's 3. It means it's a straight line over 3. It's passing through all the x values. Therefore if it's y is equal to 3, it means x is passing through all the all the values, right? Therefore domain is all the real numbers. And the second equation, 2.5t square plus 60, it's a quadratic function, and you know it's passing through all the way to the all the x, is passing all the axis. Therefore it's the domain is all the real numbers. And if you find the derivative, it's 5t plus 6, it's a straight line. Therefore it's passing all the x values. Therefore domain is all real numbers. Let's do the third question right here. F of x is equal to x squared minus 2x cubed and 2x cubed, and they are asking to find the derivative of this. To find, let's use the same equation right here. F prime x is gonna be limit h approaches 0, f of x plus h minus f of x over h. And if I find f of x plus h, so instead of x I'm going to plug x plus h square minus 2x plus h cube. So and this is the value for x plus h. Let's expand this one, x plus h square, so x plus 2xh, x square plus 2xh plus h square minus 2 times, if I expand x plus h, h cube. So there's a definition to expand this cube function, so x plus 3 cube expansion. So these are the formula for expansion of cube functions. So if I expand this x plus 3 cube, it's gonna be expand like this. The expansion will be like x cube plus 3x square y. So in this case, it's 3x square plus 3x square h, 3x square h plus 3x h square plus h cube. So this is the expansion of this x plus h h cube, right? Now let's add it together and see what happens. X square plus 2xh plus h square minus 2x cube minus 2 times 3 x square h is going to be minus 6 x square h minus 6 xh square minus 2h cube. And if I put the f of x, it's going to be same value like this because the x is already plugged like this. Let's put this in the limit and see what happens. So it's going to be x square plus 2xh plus h square minus 2x cube minus 6x square h minus 6xh square minus 2h cube, and then I'm going to put this value right here. It's gonna be minus x square minus 2x cube over h. So now I have to cancel what I can cancel. In this case, x square cancels, and this will become plus 2x cube. So plus 2x cube and minus 2x cube cancels. We have only these things left. Let's write the remaining values. 2x limit h approaches 0, 2xh plus h square minus 6x square h minus 6xh square minus 2h cube over h. Now limit h approaches 0, I can take the h common. H is going to be h common, and remaining values are 2x plus h minus 6x square minus 6xh minus 2h over h. H cancels. Now I can plug the 0 for h values. So all the values, all the h will become 0. This one becomes 0. This one becomes 0. This one becomes 0. The remaining are 2x plus 6, 2x minus 6x square. This is my final answer. And the question is asking find the domain. For in this case, this is like quadratic function. So the domain is like all the real number, and Domain of derivative, same thing, because minus 6x square minus 2x mean plus 2x is same thing. It's a quadratic function, therefore the domain is going to be all the real numbers. So let's do the next one right here. The next question is g of x is equal to square root of 9 minus x. Let's do the derivative equation. F of x is equal to limit f prime f prime x is equal to, now this is g prime x is equal to limit x approaches 0, and this is f of x plus h minus f of x over h. In this case, f of x plus h is equal to square root of 9 minus, instead of x I'm going to put x plus h, and this is going to become 9 minus x minus h. Then what I have to do is I have to find g of x. It's already found here. This is g of x plus h, this is g of x. So it's already found here, 9 minus x is the g of x. Let's put the value here. Limit x approaches 0, and we have this value right here is square root of 9 minus x minus h, and minus square root of 9 minus x over h. So to get rid of this square root, we had to multiply this one by positive square root in both sides. Limit h approaches 0, 9 minus x minus h minus square root of 9 minus x over h multiplied by square root of 9 minus x minus h plus square root of 9 minus x. And if I multiply on top, I have to multiply in the bottom too. It's going to be 9 minus x minus h plus square root of 9 minus x. So this one, the square root will be eliminated, therefore it will become 9 minus x minus h minus 9 minus x in the bracket over h square root of this, multiply together, 9 minus x minus h plus 9 minus x. Now if I expand this one, 9 cancels, and this will become plus x, and this is minus x, x cancels. The only remaining thing is minus h over h and square root of 9 minus x minus h plus square root of 9 minus x. So don't forget to put limit x approaches 0, limit x approaches 0. So h cancels, the top part is negative 1 over limit x approaches 0. The bottom part is going to be 9 minus x minus h plus square root of 9 minus x. Now I can plug the 0 value in the bottom, so the final answer will be minus 1 over 9 minus x square root of 9 minus x plus square root of 9 minus x. So the end, at the end, the answer will be like minus 1 over 2 square root of 9 minus x. That's the final answer. This is the derivative of this equation. I hope you guys like this video. See you next time. And the domain, okay, I forgot to mention the domain. So in this case, minus x plus 9. If you rearrange the equation, it's minus x plus 9 and it's in the square root. So first of all, whatever the in the square root, it shouldn't be equal to 0. Therefore, negative x shouldn't be equal to minus 9. So therefore, x shouldn't be equal to 9. So from the 9, for this graph, if you draw this graph, it starts from the 9 and it's reflected in the y-axis because it has negative sign. Therefore, it's reflected in the y-axis. I show you the graph for this one, so it will be clear for you. So let's draw the graph for this one. The graph is going to be like g of x is equal to square root of 9 minus x, right? 9 minus x, the graph. So if you see the graph, it's starting from the 9 because it can be 0, but it shouldn't be less than 0 because negative value cannot be in the root square root. Therefore, starting from the 9 and it's reflected on the y-axis and the graph go like this. Therefore, the domain is negative infinity to 9. And derivatives. What is the domain of derivative? It's gonna be same thing. Let's see what happens. Negative 1 over square root of 9 minus x. This is the graph for the derivative. It's the same thing, starting from negative infinity to 9. That's the domain. I hope you guys like this video. See you next time.